Remember that all quadratics have a built-in relative extreme value, relative maximum, or relative minimum, where that happens to live at the vertex. And even though we're stacking this in with general form things, it can work in exactly the same way for exactly the same reason in terms of the vertex form, where for us, if a is greater than 0, that is, if the parabola opens upward, then the vertex is a relative minimum because it's at the bottom. And then if a is negative, like we saw in both of our examples so far, then we have something that opens downward, so that would be a relative maximum at the vertex. Well, let's get another quick example here for exactly how this looks. For this, we have the function f of x equals 3x squared minus 12x plus 750, and we want to determine where the extreme value is as well as what kind of extreme value we're looking at. And in this case, since a is equal to 3, without doing any math, we know that what we're going to have in this case is a relative minimum, a relative or local minimum, because the parabola is going to be opening upwards. And to actually find that, we also need, in this case, because we are in general form, that b here will be negative 12, and so our vertex, or in this case, our relative minimum, will be, again, at the point negative b over 2a, f of negative b over 2a. So something like negative 12 over 2 times 3, and f of negative 12 over 2 times 3. Should make that a little bit curvier. Where up to weird notation with having to fit that space, we would end up getting here negative 2 times 6 would give us 2, along with f of 2, which ends up being, I'll put this in parentheses just for the sake of having it stuck together, 3 times 2 squared minus 12 times 2 plus 750. 75, excuse me, or the point 738, because you'd end up with 2 squared is 4, that would be subtracted from, kind of, 2 times, or 2 squared is 4 times 3 is 12, you'd have 12 minus 12 times 2 is 24, so you'd have negative 12, plus 750 would give you 738. So you have that the relative maximum in that case lives at the point 738. Excuse me, not the relative maximum. Oh boy, that's quite a large minimum. This is a funky looking function. You see a number like that and even my head automatically thinks it should be a maximum, but it's actually not. That thing just keeps going forever and ever. But looking at this sort of thing, it's important to notice here that because these types of functions have natural optima, natural extreme values built into them, they're natural candidates for certain kinds of optimization. And we're going to get a little bit of that to finish the section.